students, in this video we see the topic electrochemistry book back short answer question with answer part 2, question number 18, 19, 20, 21. Last video we saw the part 1. Okay, before watching this video you subscribe this channel and press the bell button and click the link for notification. Okay, thank you. Now we see the problems. Problem number 18. Calculate the standard EMF of the solution cadmium 2 plus bridge salt bridge copper 2 plus copper. This cell we determined the cell reaction, the standard reduction potential of copper 2 plus to copper 2 plus salt to copper metal, and cadmium 2 plus to cadmium are 0.34 volt and minus 0.4 volts respectively. Predict the feasibility of the cell reaction. Feasibility of this cell reaction means it is possible or not. You tell about the cell reaction. Okay. Now solution. Solution is what are the data given in this problem? Standard reduction potentials of copper 2 plus to copper 0.34 plus positive 0.34 volt, and cadmium 2 plus to cadmium minus 0.40 volt. Okay. Now cell notation is already given in the problem. Is cadmium 2 plus, salt bridge copper 2 plus copper. Half cell reactions. What are the half cell reactions? This is oxidation and this is reduction part. Oxidation part and reduction part. Oxidation part cadmium 2 plus. Cadmium releasing 2 electron. Releasing 2 electron means 0 to 2 plus means it oxidation. It takes oxidation. Oxidation point minus it give the 0.4 volt. This is the reduction. Okay, cadmium 2 plus to cadmium. But in this cell cadmium 2 plus. So the oxidation potential instead of minus we write the plus notation. Okay, 0.4 volt. Next, reduction in cathode. Reduction in cathode means copper 2 plus accept 2 electron from cadmium changes to copper. So reduction potential already given that plus 0.34 volt, here also plus 3 point, same value. Okay, E0 cell is equal to we know that the formula E0 cell is equal to oxidation and E0 reduction. E0 cell is equal to 0.4 plus 0.34 is equal to 0.74 volt. So this is the value, total EMF value. Okay, total EMF value positive. Here the value is positive. So according to thermodynamics, delta G is equal to minus value. So this reaction is feasible. Okay. Next problem, 19th problem. In fuel cell, hydrogen and oxygen gas react to produce electricity. Assume that in this process hydrogen gas is oxidized at the anode. This is a condition. Oxidation, hydrogen is oxidation and in anode, and oxygen at cathode. If 44.8 liter of hydrogen at 25 degrees C and 1 atmospheric pressure. This is the SCP value. 44.8 liter of hydrogen and 1 atmospheric pressure reacts in 10 minutes. Time is 10 minutes. The average current. What is the average current produced? I value. You find the I value. If the entire current is used to electrode deposition of copper from copper 2 plus salt, what is the amount deposited copper? Okay, how many grams copper deposited? You find it that. Okay, now this is the big problem. You carefully watch it. Solution: First you write the data. 44.8 liters of hydrogen at 25 degrees and 1 atmosphere pressure reacts in 10 minutes. This is the given data. Okay, 44.8 liters of hydrogen, 1 atmospheric pressure reacts in 10 minutes. The chemical reaction in anode. First anode, you write the equation. Hydrogen plus OH minus, 2 OH minus gives H2O and loss 2 electron. Loss 2 electron because oxidation takes place. Hydrogen gas is oxidized, so releasing 2 electron. From this equation, how many electron releasing? 2 electron releasing. 1 mole of hydrogen gas produces 2 moles of electron. Okay, 1 mole of hydrogen. This is 1 mole of hydrogen releasing 2 mole of electron. 2 mole of electron. Okay. Now 1 mole of hydrogen occupies 22.4 liters. This is the STP value, standard STP value. 1 mole of hydrogen occupies 22.4 liters. Now number of moles of 44.8 liters already given in question. 44.8 liters of hydrogen reacts. Okay. Now 1 mole of hydrogen occupies 22.4. Therefore 44.8 liters hydrogen gas produced is equal to 1 mole divided by 22. 1 mole volume 22.4 liters into 44.2. So cancel it. 22.4 cancel 2 moles. This is the number of moles hydrogen gas produced. 44. In question 44.8 liters. So 44.8 liters gas produced 2 moles. Okay. Next part. 2 moles of hydrogen gas produced 4 moles of electron. 2 moles of hydrogen gas produced 4 moles of electron. How many Faraday? Charge is 4F is equal to Q. Q value is 4 Faraday. Because 1 mole is 2 electron. 2 moles is 4 electron. Okay. So charge is 4 Faraday. Q is equal to 4 Faraday. You already know the formula. Q is equal to IR. So time is already, we know that 10 minutes. 10 into 60 seconds is equal to 600 seconds. We change the unit in seconds. Therefore 4 Faraday is equal to I into 600. So I want current. I is equal to 4 Faraday divided by 600 is equal to 4 into 96,500 coulomb. C means coulomb divided by 600. So 30. This is the value 38,600. Sorry, 3,860. 3,860 by 6. Cancel it. 643.33 value. 643.33 value. This is the current value. Now next, electro deposition of copper. The chemical equation is already in the beginning of the problem. Copper 2 plus accept 2 electron gives changes to copper. This is the equation. Okay. Now we find the deposition of copper. 2 Faraday charge is required. Here 2 electron accepting 2 electron. So 2 Faraday required to deposit 1 mole of copper. 1 mole of copper. Copper is in front of copper, number 1. So 2 Faraday charge required to deposit 1 mole of copper. So the current produced in the fuel cell, 4 Faraday charge utilized for electrolysis, 2 mole of copper is deposited. So 2 into 63. This is the conclusion for this problem. Okay. Entire current produced in the fuel cell, that is 4 Faraday charge, is utilized for electrolysis of 2 mole of copper. So 2 into 63.5 is equal to 127 gram. So I is equal to yeah, already this is the weight of the copper deposited in this cell. Okay, 127, 2 into 2 Faraday, sorry, 2 mole, 2 mole into 63.5. 63.5 is equal to 127. Here already write the steps. 2 Faraday charge deposited, 1 mole of copper, that is 63.5. This is the fixed value. So 2 mole of copper, 2 mole of copper means 63.5. This is this conclusion from this equation. 1 mole of copper, 2 Faraday charge required. So 2 mole of copper required 4 Faraday of charge. So 2 into 63.5 is equal to 127 gram deposited. Okay, this is the final answer for this question. 127 gram copper deposited. Already know that I is equal to 643.33 ampere. This is the conclusion. Okay. Next problem, 20th problem. The same amount of electricity was passed through the two separate electrolytic cells, cell 1 and cell 2. So the solution of nickel nitrate, the solution of nickel nitrate and chromium nitrate respectively, the salt solution, nickel nitrate and chromium nitrate, in two cells. 2.935 gram of nickel is deposited in the first cell. What are the amount? Same current passed through the cell. So chromium, how many grams deposited? Already given that 2.935 gram nickel deposited. Now chromium, we find the chromium. The molar mass of nickel and chromium are 58.74 and 52 gram per 1. Okay, this is the data. Okay, now what are the solution? Find the solution given the data. Write the given data. Weight of the nickel deposited in the first cell 2.935 gram. Molar mass of nickel already given that 58.74. Molar mass of chromium 52 gram per 1. Okay, this is the data. Now the steps. If the cells containing the solution of nickel nitrate and chromium nitrate in cell 1, the solutions are given solutions are nickel nitrate and chromium nitrate. Two solutions are taken in the cell 1 and cell 2. Now cell 1 nickel deposited how many grams? Already wrote that 2.9 nickel deposited 2.935 gram. Okay. Now the equations are nickel nitrate NiNO3 twice, chromium nitrate CrNO3 thrice. So the equations are Ni2 plus 2 NO3 minus. I write it the anion and cations. Nickel 2 plus and 2 NO3 minus. Okay. Chromium 3 plus 3 NO3 minus. Okay. Now nickel 2 plus gaining 2 electron. Gaining 2 electron changes to nickel, depositing nickel metal. Nickel 2 plus salt acquire or gaining 2 electron. Okay. Chromium 3 plus gaining 3 electron. Changes to chromium in cell 1 and cell 2 respectively. So the two chemical reaction from these two chemical electronic off cell reactions, the two off cells reaction, Ni2 plus changes to nickel for gaining 2 electron, chromium 3 plus gaining 3 electron. So from this equation write the conclusion. 2 Faraday charge, first equation 2 Faraday 2 electron releasing. So 2 Faraday charge deposit 58.74. 58.74 means the value of molar mass. So nickel nitrate. 3 Faraday, 3 electron gaining. So 3 Faraday charge required to deposit 52. This is the molar mass of chromium. In both cells, same current is passed. This is the condition. So 2 Faraday charge required to deposit 58.74. So 2.93 gram deposited in cell 1. The amount of charge passed through the cell, 2 Faraday divided by 58.4 into 2.935 gram. I want to find the nickel. How many grams are nickel deposit? 2 into Faraday. 2 into 2.935 divided by 58.74. 58.74 Faraday. Okay. So 5.87 divided by 58.7. Okay, cancel it. 0.1. This is the charge required for nickel deposit. 0.1 Faraday. The charge required for nickel deposit 0.1 Faraday. So same amount is produced chromium. So 0.1 Faraday passed through the chromium nitrate. Chromium deposited is equal to 52 gram. Already know that molar mass of chromium 52 divided by 3 Faraday into 0.1. So 52 divided by 30 is equal to 1.733 gram. So this is the final answer. 1.733 gram of chromium is deposited. Okay, I make the calculation in the steps, division. So 52 30 divided by 30. Next question number 21. A copper electrode is dipped in 0.1 mole copper sulfate solution at 25 degrees centigrade. The copper electrode, metal electrode dipped in this much more concentration of solution in the cell. Calculate the electrode potential of copper. Now given the data, copper 2 plus 2 copper. Copper 2 plus 2 copper is equal to plus 0.34 volt. Now what are the data? Concentration of the copper sulfate solution 0.1 mole. You know that this is the concentration. Now EMF value E0 copper 2 plus 2 copper 0.34. E cell, we find the E cell value. Now the cell equation is copper 2 plus gaining 2 electron. Gaining 2 electron, 2 changes to copper. Copper 2 plus 2 copper. Therefore copper 2 plus gaining 2 electron to copper. So E cell is equal to E0 minus 0.0591 divided by N into log copper divided by copper 2 plus. Copper divided by copper 2 plus. Now E0 value, I know that 0.34, already given that 0.34 minus 0.0591 divided by 2. 2 means we know that the 2 electron gaining. So number of electron 2. Log copper value is already metal. This is a metal. Metal value is 1, common 1 value. I already write in the note. Copper solid is equal to 1. So N is equal to 2 electron. Copper log 10 is equal to 1 value. Log 1 divided by 0.1. So 0.34 minus 0.0295. I cancel the numerator and the denominator. So log 1 divided by 0.1 is right to 1 by 100. So 0.34 minus 0.25 into log 10 is reciprocal to numerator. So log 10. So 0.34 minus 0.0295 is equal to already know that log 10 value is 1. So 1 is equal to 0.3105 volt. I already subtract the value. So electrode potential of copper is 0.31 volt. This is the final value for this question. Now thank you for watching this video. Subscribe this channel for notification, and the link press the link in description. So thank you.